Well, this raises the whole question of food. Then, surely there's some. You yourself must have longed for a green vegetable once in a while.
Well, I did it first. My first experience was that a ship that was supposed to meet me didn't meet me. And I had to become a guest of the Eskimos, and for 4.5 months I lived on literally nothing but fish and water. Well, we had some blubber, some polar bear blubber, but apart from that, and at the end of 4.5 months I was healthier than I'd never been before. And enjoying every meal and feeling fine.
And this is on an exclusive meat diet?
That was exclusive fish in this case. Fish. I have since then spent more than 6 years on red meat. That is seal meat, caribou meat, muskox meat, polar bear, grizzly bear, and so on. You have to have fat with a lean. Lean and fat together make a perfect diet. A balanced diet.
A balanced diet.
Balanced diet. You have everything you need if you have both lean and fat. You don't have to eat any organs. That's a peculiar folklore.
Oh, is that
we
so?
We feed the organs mostly to the dogs.
Hello everyone, welcome to the channel. Today I have a great returning guest. We are joined with Professor Bart Kay. This is an interview I did with him recently, and we're talking about protein, what it is, what it does, and we also talk about food combinations such as carbohydrates, proteins, and fats, and the effect on the body and disease. So I hope you're. Let's start with protein. What is protein for the human body?
Right, so every protein in the human body is made up of a string of amino acids. And there are a number of different amino acids that make up proteins. And as long as our diet contains a sufficient amount of all the amino acids that are essential in our diet, because we can't make them ourselves, then we have the building blocks to make all the proteins that we need to make. Precisely because human beings have evolved over at least 4.5 million years consuming a particular diet, that being a diet based on the flesh of mostly large ruminant animals, our bodies are attuned to getting all our essential amino acids from meat. And it turns out, funnily enough, that meat, the very thing that we are ourselves made from, contains all the right amino acids in the right amounts. Gosh, what a shock. And therefore, it's not a struggle to get what we need protein-wise by eating meat. Can you get all the essential amino acids through your diet if your diet doesn't have any meat in it? Let's say it's all plants. Can you do that? Yes. However, how much food do you have to eat to get them all? And in the right amounts? It's a vast amount.
Yeah.
It's a huge amount. Also, there are those that would argue that plant-based protein is not as bioavailable. The body doesn't respond to it as well. It's not as good somehow. Whether or not that's true, I don't know, and I don't really care, actually, because at the end of the day, to get all the essential amino acids I need in my diet from plants, I would have to eat a prohibitively large amount of plants. End of discussion on that for me.
Yeah. So, while we're talking about plants, and amino acids, now there's, can we break that down even for like such as proteins such as collagen, and what role that has in the effect that has on our body?
Sure. So collagen is by far and away the most important, the most prevalent protein found anywhere in the human body.
All right.
Collagen is made up of a certain sequence of amino acids put together in a certain chain, which then folds up on itself in a certain way to take a certain shape, as do all proteins. And that's really all it is. There's nothing mystical or magical about collagen or any other protein. A protein is a string of these amino acids put together, starting here, ending over there, And then because of the positive charges on the different amino acids and negative charges, the thing folds up into a functional shape when it's generated as per the instructions of the genes. That's what a gene is, by the way. When people talk about your genes, a gene is a length of DNA encoding for the production of a particular protein and nothing else.
Yeah.
Nothing else at all.
So going back to plants, is collagen being so that it's so important, is collagen something we can get from plants?
Collagen in the form of formed collagen, no. That's an animal product.
Yeah.
Okay. Now, your body can generate collagen itself from constituent amino acids from the ground up. It can do that. But that's the long way around. That's the hard way around. If you could feed your body collagen in two halves, two peptides, let's call them type 1 and type 3 collagen peptides, just because that's important.
Yeah.
We can feed ourselves type 1 and type 3 collagen peptides, and the body will recognize those as soon as it absorbs them as a type 1 and a type 3 collagen peptide. And then all it needs to do is get a vitamin C molecule in between them. Bam. That links them together. The deactivated vitamin C is then ejected, and you've got collagen. That's the short way around. So people that take collagen peptide supplements, that's why they're doing it.
Yeah. All right.
Because as we age, even those of us that live reasonably good lifestyles and have reasonably good or even very good diets, if there's going to be a problem in producing any of our proteins, it's going to be collagen, precisely because it's the most common.
Yeah.
Almost all your proteins contain collagen in your body.
Okay. Yeah. So you need vitamin C for that activation?
Yep.
Okay. So why would you not need to supplement vitamin C on the carnivore diet then?
Well, because the reason that the recommended amount of vitamin C is what it is that it assumes you are consuming a diet which is rich in carbohydrate. And it assumes that because that's the advice they give you. Eat a bunch of carbohydrates. Why would your carbohydrate intake affect your need for vitamin C? Well, here it is. There is a transporter on the membrane of every cell in your body that has a role, and the role of that transporter is to take vitamin C, move it across that membrane from the exterior to the interior of the cell. It imports vitamin C.
Yeah.
Do you happen to know off the top of your head, DC, do you know what that transporter is called?
No, not off the top of my head.
No, most people don't. It's GLUT4.
GLUT4.
Right, which is the same one that transports glucose. Glucose and vitamin C are on the same transporter. So if you've got a bunch of glucose fighting its way into your cells using that transporter, you need vastly more vitamin C to be able to have enough force, concentration force of vitamin C to push through there to get any vitamin C into your cell.
Yeah.
So you need a vast amount of vitamin C on a on a carbohydrate-based diet.
Yeah.
That's why the ADA recommendations for vitamin C are X number of milligrams per day, blah, 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 blah.
So I think I've heard this explained before. If you're on a high carbohydrate diet and you're trying to get the recommended amount of vitamin C or the absorbable amount, it's kind of like forcing two fat guys through a thin door.
Yeah, exactly that.
Yeah. Okay.
And they get in each other's way and jam each other up. And the weight force of glucose being vastly more than vitamin C will push vitamin C out to the side so that it can't get through that transporter. Right. So you need to up your vitamin C quite a lot to get it into your cells because of the glucose problem.
Yeah.
So stop eating carbohydrates altogether, and now your GLUT4 transporter is free and laden down with a whole bunch of glucose. So now it can move all the vitamin C it likes. It turns out then that as a carnivore, your actual requirement for vitamin C is in the micro milligrams range.
Would that be the same for most other elements such as zinc and anything else?
Well, most of those have either independent specific transporters, co-transporters. Most of those don't go through that same transporter. So that same issue wouldn't be expected to be in effect there.
If I remember correctly, too, we also produce a certain amount of vitamin C through muscle contraction for. I'm talking about calcium, aren't I? Yeah, I think I'm talking about calcium. But the body does produce some vitamin C as well, does it not?
Well, the gene that encodes for making vitamin C, or encodes for the enzymes involved in the processes that make vitamin C, I should say.
Yeah.
They are completely knocked out in the human genome. There is not one human being alive that has that gene to make their own vitamin C. Now, it's possible that vitamin C might be being generated, say, in the gut lining by certain bacteria doing certain things on certain other things. A little bit, sure. Yeah. But the actual endogenous production of vitamin C is completely knocked out in human beings. None of us, no human being alive can make their own vitamin C according to a genetic instruction to make that enzyme that causes
That would that explain the reason why that on a proper human diet the necessity for vitamin C is in the microbes, because we just don't need it that much.
Correct.
If we needed it, we would produce it. Yeah.
Well, here's the thing with genes. A gene that is useful survives, is passed on.
Yeah.
A gene that is neutral, neither helpful nor unhelpful, generally also will be passed on.
Yeah.
Because it's not deleterious, it's not a problem. The only time a gene can be completely knocked out in a species is if the production of that thing is definitely a problem.
Yeah.
Now, this is a theory. This is not, because I'm all about the science and I'm always on about, let's be clear about when we're stating a theory. So here is a theory, an idea. Our ancestors circa 5 million years ago lived in trees, ate leaves and fruit when it was available, a carbohydrate-based diet, and also had, therefore, the ability to produce our own vitamin C. We had a gene for that. Like just about every other mammal in existence has this gene. They can make their own vitamin C. Humans, I'm guessing at a time of scarcity of food, maybe it was a sudden glaciation, a change in climate or something, an ice age began or whatever it was, suddenly it wasn't so good here in the trees. And humans decided to climb down from the trees, stand upright. Oh, look at all these lovely woolly mammoths. Maybe they're tasty. Let's dive at them headlong with our mouths open, with our sharp, pointy teeth. Oh, no, hang on. They used sticks and bows and arrows and things and rocks, and they worked together and they yelled and they scared the animals and they corralled them over cliffs and things like that. That's how they did it. And they started eating all this meat and not eating so much carbohydrate at all. But they were still able to, and they were still making all this vitamin C in their bodies.
Yeah.
Vitamin C that you don't need, that you can't use, most people will tell you, oh, you're just weird out.
Right.
And that's true to some extent, but that's not all of it. There is an amount of vitamin C excess that doesn't get urinated out. It stays in your body and it gets metabolized to something else. Do you know what that is?
No, I don't.
It's oxalate.
So a high vitamin C diet is going to give you high oxalates then.
if you're not using the vitamin C because you don't need to anymore because you stopped eating carbohydrates, now you're eating meat.
Yeah.
So everyone that had the gene functioning to make vitamin C poisoned themselves to death with their own endogenously produced oxalate gas, and that wiped out the gene completely. So that only humans with a dysfunctional copy of that gene could survive. Now, every human being on the planet has not got a functional gene to create the enzyme that'll make vitamin C. I think that's the reason. That's my guess.
Yeah. Yeah. Well, yeah, I suppose it's, I mean, it makes sense, but it's impossible to really study on. Yeah.
Of course I can't prove it, but that's my theory on it.
Yeah.
I also have a theory on brontosauruses, if you like.
Yeah, sure.
I stole it from Monty Python, but here it is. Brontosauri are all very, very thin at one end, very, very thin at the other end, and much, much thicker in the middle.
From eating carbohydrates.
Well, probably. Yes. Yes.
Yeah. Yeah. Androids. Yeah. Very good. All right. So the best source of protein, obviously, for bioavailability, just sheer number of or amount of food that we have to eat, obviously, is animal products. So how much protein should someone be eating then?
I always suggest to a person that a good level is somewhere between 1.75 and 2 grams of protein per kilogram of idealized lean body mass.
Right.
So
ideal weight.
Right. So how would you work out your ideal weight? Well, you would take a BMI of 22.5 and you would multiply that by your height in meters squared.
Right.
And that will give you a number of kilograms that your body should ideally be, assuming a number of things. Assuming you are of European descent and not African or Asian, for example.
Yep.
Assuming that you are normally muscled and not highly muscled or highly under-muscled, which you might also be. What I'm saying is it's a parsimonious assuming a whole bunch of things.
Yeah.
But that would be give or take your ideal mass.
Yeah.
That's the figure you use to work out the 1.75 to 2 grams of protein. And to work out a weight of meat that will equal that amount of protein, you have to multiply the protein number by 4 because raw meat is almost entirely made of water.
Yeah. Yeah. Yeah, that's right. Yeah, so, okay, so I've recently heard, I was speaking to Anthony Faiz. He actually has a good measurement here. I thought makes sense as well. If you measure 1 gram per centimeter height, it's a short, like that would be the minimum protein intake.
Okay.
Yeah.
Mm-hmm. Yeah,
that would work.
That could work too. Yeah, that could work too.
Yeah.
That would be a similar sort of number usually for most people. Again, assuming that you're not hugely underweight or hugely overweight in reality.
Yeah.
But it's all about
depending on activity as well.
Yes.
Yeah, activity has a lot to do with it. And when it comes to protein, I mean, there's always a lot of I know vastly, like usually people will say like say 0.8, like for a sedentary person, 0.8 grams per kilo of body weight. It's always per kilo of body weight. I've seen some studies or papers of athletes taking upwards of 4 grams per kilo of body weight, and some even higher, up to 6 grams.
Yeah.
So I always recommend people when they do a calculation of their ideal weight that should be their minimum, and it should be a progression. As you get used to high protein diets, you should progress. So let's start from the minimum and then work your way up. Would that make sense? Yeah.
Absolutely. The thing I would keep an eye on is I would be tracing a person's A1C.
Yeah.
Reason being is that if your protein intake is excessive for your actual needs in practice, then the excess amino acid that you take in is likely to be transmuted to sugar and thence to de novo lipogenesis, i.e. fat production, and then stored on your body as fat. But the first thing that will show up if your protein intake is higher than it needs to be will be that your A1C will drift up, 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 up. Now, when I say drift up, I'm talking about well over 6.
Yeah.
Carnivores are often presenting with baseline A1Cs around 6.
Okay.
Which our antithesis, our opponents, the Vagoons, which they are pointing at and saying, look, there's a reason why your diet's no good. Your A1C is high.
Yeah.
Forgetting entirely that A1C is the average value over the last X amount of time. It doesn't give you what it was at any given time.
Yeah.
Now, a carnivore will produce an A1C line over time that's pretty stable. Sorry, a blood glucose over time. So if you had a blood glucose monitor on, a continuous monitor, that person's blood glucose throughout the day, every given day, will be very stable with very little change.
Yeah. Yeah. That was going to be my next question, actually. How would it affect
that? Well, there you go. Well, whereas a person that eats a lot of carbohydrate will get blood glucose over time that does that.
Yeah.
Now, both those people might have an average of 6, an A1C of 6.
Yeah.
However, the person whose blood glucose is doing that, up and down, that's where the damage is done, up there.
Yeah.
13, 14, 15.
Yeah.
6 is not a problem. If your blood glucose is consistently 6, who cares?
Yeah.
Yeah.
Yeah. So that's the difference between eating too much protein and eating too many carbs.
Mm.
Yeah. So you get that high spike in carbs.
Yeah. So if you're eating a carnivore diet, no carbs to speak of, and your A1C gets up to 6.2, 6.3, 6.4, then you are eating too much protein.
Right. Okay.
Yeah.
So next question, talk about combinations of foods. Now, back in the day, athletes like Vince Gironda, he was a big opponent for the steak and eggs diet. He ate 36 eggs a day for the testosterone boost and that sort of thing. But he did eat carbs, but he always ate proteins and carbs separately. Why would you separate your carbs from proteins?
Well, there would be no reason in my mind to specifically do that. Other than in the stomach, you need an acidic situation for meat to be broken down. But to break down complex carbs, you need a basic pH.
Yeah.
In other words, there is a problem there. That's the only one I can really think of. I would go a step further than that, however, DC, and I'd go, well, hang on, why the hell are you eating carbs at all?
Yeah.
Why are you doing that?
Yeah.
Never mind separating them out. Get one of those things out of your diet and leave it out.
Yeah.
Yeah.
Yeah, I agree. I just don't see the point in actually. I mean, if you're going to separate them anyway, why bother eating them in the first place? But I was looking at an article on the Mayo Clinic. Now, this is just beyond understanding, really. But they've got here, what does 15 to 30 grams of protein in whole foods looks like? And at the bottom, they've got protein should accompany fruits, vegetables, and whole grains. Protein should not be the entire meal. If you feel like you might have increased protein needs, consider adding more beans, lentils, soy, rather than processed supplements.
Right. Okay, so what you've got there is something written by a plant-munching idiot.
Yeah. Yeah, exactly.
That's really all we need to say about that. That whole statement you've just given me there shows absolutely no understanding whatever of the human condition, biochemistry, anything remotely connected with human health in any way. It's just ridiculous.
Yeah, that's right.
Yeah.
So that's my point. Like this is the Mayo Clinic, and this is why I think it's so confusing for people. So when we're talking about the sources of protein, obviously we've already established like animal based are the best for human consumption.
Yeah.
But you obviously have these other people pushing soy and lentils and beans and all seeds and that sort of stuff.
Yeah.
So what is and granted they do have proteins, but they just don't have all of the proteins. But what are the other problems that come with these?
Well, number one, you've got to combine all sorts of different plant-based sources of protein to ensure you get the full spectrum so that you actually can effectively build protein. So that's the first problem. Plant toxins, anti-nutrients, phytoestrogens are all significant potential issues with all of that.
Yeah.
And added to that, the anecdotal, I guess, indication, it seems very, very clear to us, is that animal protein seems to be vastly superior in terms of its bioavailability, and it does not irritate, inflame, cause anti-nutrient problems, fill us up with oxalates, etc.
Yeah.
And it's in line with our genetic gift, our anthropological past, the way we've evolved as a species over millions and millions of years. It's only the last 11,000 years or so that we've added any significant amount of plant material to our diets at all. And those plants that we do eat now are human inventions, every one of them.
Yeah.
It just seems illogical to state that you can do as well on a plant-based diet protein-wise as you can do on a meat-based diet protein-wise. All you need to do is look at any promoter of plant-based diets and put them up against any promoter of animal-based diets, with the caveat that both those individuals will be tested for gear. Are they taking the juice?
Yeah.
Any pair of people that you assess, pairs of women, pairs of men, age matched, whatever else, every single time the meat eater will be in a better situation than the plant eater.
Yeah. Yeah.
If they've been stable on that diet for 5 years or more.
Yeah. Yeah,
Every
I
time.
agree. Like, yeah, definitely health-wise anyway.
Mm.
So back onto combinations, fats and carbs together.
Yeah.
Why is that a problem?
Fats and carbs together activate a part of your metabolic pathway, which is collectively being referred to these days as the Randall cycle, which is strange because it is not a cycle at all. It's got nothing to do with cycle. It's just a strange thing, but there you go. When you try to metabolize fat and carbohydrate at the same time, they cross-inhibit each other at the mitochondrial level, thus meaning that the redox potential, the energy production potential of your cells drops, thus meaning the inflammatory status of your cells goes up necessarily and concomitantly via an increase in inorganic phosphate in the cell fluids.
Okay.
That inflammation, if it's chronic, leads to atherosclerosis, strokes, heart attacks, most forms of cancer, most forms of dementia, all the big killers.
Right.
Inflammation.
Yeah. Okay, so fats and sugars being the baseline problem of that together. Would that be including the seed oils and sugars?
Seed oils and sugars will react in that way, but seed oils are vastly more problematic again than healthy animal fats.
Yeah.
Precisely because seed oils are themselves also directly pro-inflammatory without any help.
Right.
Whereas animal fats are not.
Yeah. So you're getting high inflammation from the sugar and the omega-6s in the seed oils.
Yep.
All right. So things like protein bars, protein powders, things like that will give you that same problem. Yeah.
If they've got any of that kind of crap in them, yeah.
Yeah. Which most of them do.
Yeah.
9 out of 10, I would say, do.
Yeah.
So how does that affect a low-fat diet?
Mm.
If you're on a low-fat diet and...
Okay.
Yeah.
Right. So a person that is eating a low-fat diet for some specific reason medically, okay, that person will be given that advice medically for some reason. They'll be following that medical advice. That's not the person I'm talking to here. You do what you need to do. There are one or two conditions that do exist where a person can't do well on a high-fat diet. Okay. For the vast majority of people, that aside, the human condition is, the human genome is, the human biological systems, our organ systems, our pathways, all of that. You are absolutely designed by at least 4.5 million years of selection pressure to gain the vast majority of your so-called energy from fat, animal fat. That is how it's supposed to be. So if you're eating a low-fat diet for any reason other than on medical advice because you have a problem, specific problem, then you're doing the wrong thing.
Yeah.
If you have been sucked in by that other crowd of people who promote plant-based diets, who tell you, oh, all you need to do is eat plants and get all that fat out of your diet, that'll solve your problem, then you have been sold a bill of goods that will not actually withstand refutation. Here's the reason. While eating a very low-fat, much more high-carbohydrate diet will alleviate the Randall cycle issue exactly the same way that a carnivore diet will actually.
Okay.
One of those diets, meat and animal fat only or plants only, one of those diets is destitute in terms of nutrients required on a daily basis by human beings, essential nutrients. It's the plant-based diet is the destitute one. That's the one lacking required nutrients for human beings. The carnivore diet, there is no such lack. It is complete. It is an ideal diet for a human precisely because that's what humans did eat for about 4.5 million years. Flesh and fat of animals, a few rooty tubers here and there.
Yeah.
Not carbohydrate-y ones, fibrous ones.
Yeah. So, all right. So even if you're on an animal-based diet,
Mm-hmm.
And you're on a low-fat diet, how does the rabbit starvation sort of scenario work out in form of in way of disease?
Yeah. If you're avoiding fat in your diet and your diet is based more in protein, lean meat and less fat, then you might subject yourself to this thing that DC's talking about there called rabbit starvation. It's called rabbit starvation because rabbit meat is an example of a lean, gamey meat. Venison is another, for example. If you're not getting enough fat in your diet and you're not eating carbohydrates either, then you will struggle for energy. And your body will start to shrivel up and fade away because you'll have to use a lot more of the protein you're eating to transmute to sugar for energy. Thus, you won't be able to absorb as much protein and build muscle with it. And then when that runs out or runs short, then you're actually going to start diving into your muscles, pulling the proteins out of those and turning them into sugars and fats.
Right.
Rabbit starvation. Okay. You need to eat fat.
Yeah. Yeah, that's what I keep trying to get across. I I had that problem. I was fat phobic,
Yep.
you know, and I think that would be the underlying cause for my blood cancer. So this is why I try to get across to people that you need to eat fat, a lot of fat. You know,
Yep.
not just. I think fat should be the focus, not the protein. Everyone keeps all you see on YouTube though is get protein from this protein, but you know, I think fat should be the focus.
Yes, agreed.
Yeah, at the time, you know, I didn't understand the processes of the lymphatic system, and so you know, that's something you learn the hard way sometimes. Now, as I understand it, like you just explained the Randall cycle, and you're saying that the flow. I understand it as the flow of sugar in the mitochondria disrupts the uptake of fat as energy.
Yeah.
Right.
Yes.
So you either have one or the other. If you have both, you're not only not going to get nutrients from fat, you're not going to get energy from either.
Right. Or it's limited, shall we say? Because the Randall cycle is actually a set of faders. Right. It's not a set of on-off switches.
Yeah.
These are things that can be more or less in effect.
Yeah.
And what we're saying is the more sugar trying to get through your mitochondrial pathway, the more that will inhibit the uptake of fat.
Right.
And vice versa. The more fat that's pouring through, the less sugar will be able to get through.
Yeah.
So if you've got huge stores of both fat and sugar trying to push into the mitochondria at once, the analogy I use is two fat men trying to get through a revolving door at once.
Yeah. So is that, do you think, like a defense mechanism to push out the poison sugar?
I think it is a situation that exists precisely because we have not had a biological selection pressure that required us to come up with a biological pathway whereby we could consume a bunch of carbohydrate and fat at the same time without becoming inflamed and putting on fat and throwing our metabolism into storage mode.
Yeah.
Why is that? Well, look around nature. How many foods can you find in nature, eaten by any animal at all, that contains a large amount of both carbohydrate and fat?
Yeah.
I can only think of one.
One, two.
Yeah. Mother's milk and certain nuts.
Okay. Yeah.
Mother's milk contains a lot of sugar and fat. Why? Precisely because a baby should have their Randall cycle activated, precisely in order to cause that baby to put weight on rapidly.
Yeah.
Fat, which can then use.
That's going to be the fastest growth period.
Exactly.
Yeah.
Right? Everything else in nature is either rich in carbohydrate and protein or fat and protein, not both.
Right.
So we don't have a pathway that can deal with that. Now, out of fat and carbohydrates, one of those is toxic to the human body above certain levels, and one is not.
Yeah.
Guess which one's toxic? It's sugar.
Sugar.
So what we have developed is a biological process to protect the cells from sugar damage if the sugar level is too high in the blood.
Right.
It's called the Randall cycle. It's the one I've been talking about.
Yeah.
Yeah.
Okay, and that's why it's there. So it's like a defense thing.
It is. It's a defense against the cell being damaged by sugar.
Yeah.
Yeah.
Okay. So the thing is about the Church of Veganas, they are telling us that they can get plenty of fats from the seed oils.
Right.
And that's what they keep promoting. In fact, this morning I just watched a video from talking about how safe and how wonderful soy is in and how it actually defends against cancer, even though evidence shows that it causes it. Now, apart from even if these things weren't rancid or toxic sort of machine oils and everything else.
Mm.
How is that uptake of oils compared to fat going to affect the cells or the proteins in the body
Right.
that we
Okay.
need?
Plant fats, omega-6 fats, seed oils, directly upregulate two separate inflammatory pathways, LOX and COX.
Yeah.
That's a known fact.
Yeah.
Omega-6 oils are pro-inflammatory fact. There we go, right there. Further to that, plant-based oils, seed-based oils are typically rancid, oxidized at the time that you consume them, thus leading to the consumption of very, very dangerous primary and secondary oxidation products such as aldehydes.
Right.
Not a good thing.
Yeah.
Thirdly, seed oils are much higher, it seems, in deuterium than even the omega-6 that you will find in animal fat.
Right.
And deuterium is a particular problem for energy production in the mitochondria as well.
Yeah.
So all in all, anyone who suggests that the intake of any amount of omega-6 oils is innocuous and you should do it is an imbecile, is an anti-humanist, is a misogynist, and is vastly, hugely incompetent. Further to that, Neil Barnyard, the bloke you're talking about,
Yeah.
is a theologue, is a card-carrying member, priest of the High Church of Anorexia Vegana. And all you need to do is take one look at the boy and decide whether you want to take health advice from that individual or not.
Yeah.
Irrespective of what he's got to say, take one look at him. This is a bloke who is supposed to be an MD. Does he look like a picture of health? Is he an expert in health?
Yeah.
No.
Yeah.
Yeah.
Well, yeah, exactly. I mean, that's actually, I just finished a rant video about that, about like the ADA and some of these health experts around the world. Because just take a look at them. I mean, these are the people that are dictating to us how and what we should eat. And obviously, they don't have their own health under control. Pencil next
Exactly.
it's
Self-awareness
it's
even.
unbelievable.
The fact that these people would stand up publicly in front of people on camera and profess to know anything about health and nutrition when they are either a walking skeleton, emaciated and unable to produce collagen, as it turns out, looking like they could fall over in a light breeze, doing things like Joel Kahn, breaking your foot by stepping out of the shower onto the bathroom floor. Foot fracture, that's normal.
Yeah.
And then claim you actually had a big accident that caused your fracture. No. That kind of individual with the pencil neck and the lack of muscular development and the concave cheeks and the eyeballs rolling back into the head and the grey ashen pallor, all of that.
Yeah.
The other kind of vegans that you'll see are the junk food vegans, who are all, as you say, describable as looking a lot like Jabba the Hutt.
Yeah.
Or if you want to take advice from either of those, you fill your boots up. It's your funeral.
Yeah. Yeah, it's laughable, the whole thing. I think one of the reasons behind the whole fat acceptance sort of garbage as well. It's just accepting, unhealthy. Why would you accept that? Being sick all the time.
That's right.
Yeah. It's like I said, you never trust a skinny chef, Why would you trust a fat doctor? And MDs have no nutritional sort of background anyway.
No, of course not.
Yeah. So it just goes round and round. And, of course, everyone believes an MD because they're respectable, right?
Well, some of them are.
Yeah, some of them. But unfortunately, very few and far between.
Mm-hmm.
So getting back to, seed oil, the oxidation, like that, oxidation because of the processing, the cooking, everything else, that by the time it reaches the supermarket shelves and so on in processed foods, it is heavily oxidized.
Yes,
Um,
almost
so,
certainly.
oh yeah, and so what would be the reason for why do you think the reason would be behind adding these seed oils to almost everything in our standard Western diet?
That's financial. It's
Right.
got nothing to do with human health.
Yeah.
Whatever. It is
Right.
large companies who are producing these seed oils, lobbying the dietetics associations, the governments of westernized nations, the medical schools, etc., giving them a lot of money to tell them to teach their practitioners to promote this stuff.
Right. So, would you recommend that anyone eat any of these processed foods at all, including
Not at all.
the fitness industry supplements,
No,
proteins,
I wouldn't.
protein bars,
No,
anything?
no, I wouldn't go
Nothing?
near them. No.
Okay. So they have absolutely no benefit in the. So if you are having trouble trying to get in enough protein and you're trying to build muscle, say a bodybuilder, for example, or any kind of athlete,
Yeah.
would you still not recommend anything like a supplement like whey protein or anything?
I probably wouldn't, personally. I have
Okay.
taken those things myself in the past, of course, before I knew any better when I was a much younger man. Absolutely.
Yeah.
And most of it was carbohydrate-laden junk, actually, with seed oils and stuff mixed in. Just rubbish, to be fair.
Yeah.
I'm not saying that there are no products out there that might be okay. On a case-by-case, maybe there are. What I'm saying is a generalized rule of thumb in my day-to-day practice and in my day-to-day life for my own private life, do I go anywhere near any of that stuff? The answer is no.
Right. So you've trained many athletes in the past, yeah. So what would you recommend to them?
100% carnivore diet in terms of nutrition.
Yeah. Nothing added.
Nope.
Okay. Very good. All right. That's all right. So what
Just
about
the thing is, why would you want to expedite your recovery from exercise? Because the recovery from exercise is happening because you've injured your body slightly during the exercise session. And the process of repairing that stressful situation, that's what getting fitter is.
Yeah.
So if you're shortcutting the process of getting fitter, well, what's the point?
Yeah. So if you're shortcoming the recovery, you're not getting fitter. You're just getting no benefit at all.
Well, you may case by case, you may be attenuating the training stimulus by shortening down the period of time in which the body is repairing itself and inflamed from its exercise protocol.
Right. Okay. All right. So what would be the combination of protein to fat sort of ratio? How much fat would you have compared to your protein intake then?
Right. I don't tend to worry about the ratio between those two things at all.
Okay.
What I tend to do with people is say, right, well, your individual idealized intake of protein will be somewhere between 1.75 and, at the very extreme end, 2.25 grams per kilo of idealized body weight. Or in the case of a heavily muscled athlete, and you work it out on their actual weight.
Yeah.
Right. And it's just a matter of n equals 1 dialing in on your ideal from there, which we work out using A1C tracking or continuous glucose monitoring as our guide to that. And then what you do is you fill the rest of your diet with animal fats to the point of satiety. Meaning when you feel hungry, you start eating. And when you suddenly feel like, geez, I don't think I want to eat anymore, that's when you stop eating. Even if there are 2 fork loads left on the plate or something, put it in the fridge. In some houses, it'll be there later. Not this one. But, you know.
Yeah.
Listen to your body on that.
Yeah. But okay, so for my mind is, work out your protein intake, and then up to double that in fat. Fat should be
Sure.
what you should focus on.
Yes.
So what would be the best sources, do you think? What sorts of do you eat dairy, like butter,
Right.
for example?
Yeah. Okay.
Tallow?
Yeah. So when I'm eating beef, I will often add a significant amount of butter to that, mostly because I actually remove the beef fat and feed that to my partner because I don't like it.
Okay.
If I'm eating lamb, or if we are eating lamb, the opposite happens. I will eat the lamb fat and hers as well because she doesn't like lamb fat.
Very good.
We both like pork and pork fat in all its forms, so that's fine. Occasionally we'll have fish or chicken or something else, to which is often butter added to make it fatty enough. In terms of dairy, I can't have milk myself, but I can have yogurt, unsweetened Greek-style yogurt occasionally.
Yeah.
I have been known to eat cheese from time to time of various different sorts, but I'm not a huge cheese fan in any stretch. Eggs are not a huge part of my diet either, personally.
Okay.
But mostly my fat comes with the meat. Either it's the fat that came with the meat or it's butter that's added to it.
Okay.
Yeah.
Very good. Excellent. So that should be everything everyone needs to know, I hope. Combinations, proteins, fats, get your fats in, get your proteins. And of course, the best source of proteins is always going to be animal based.
Yep.
Nutrient wise, fats, I think, also obviously going to be a lot better for you, a lot healthier than any kind of oils that you might get from seed or plant.
Yes.
So,
yes.
Okay. All right. Well, I think I can leave it there then. And thank you very much for joining me again. Thanks for taking the time out and spending it with me on my channel. And I just really appreciate having you back on.
Privilege and a pleasure. And we'll do it again soon, I'm sure.
Yeah.